Welcome back to physics class. The topic before us today is gas law. So we want to take a look at gas law, that is Boyle's law, Church's law, pressure law, Gay-Lussac law, and the general gas law. Gases are basically described under three basic properties, which are volume, temperature, and pressure. They are the state variables of gas. So Boyle's law. Boyle's law, otherwise known as isothermal process, that is, it happens when the temperature is constant. Yes, it states that the volume of a fixed mass of a gas is inversely proportional to the pressure, provided that temperature remains constant. That is, volume is proportional to inverse of pressure. So, which simply means that V equal to K over P and PV equal to constant. By PV being equal to constant, we mean that P1 V1 equal P2 V2. And if it exceeds to P3, we still have P3 V3, and so on and so forth. So, let's see how we can apply this to questions. I have a question here before us. A fixed mass of gas at a pressure of 650 millimeters mercury occupies a volume of 30 centimeter cube. What will be the volume of the gas at 760 millimeter mercury if the temperature remains constant? We have the options. So we're going to solve and see which option corresponds to the answer we have. So the data given are the P1, pressure 1 is given as 650 millimeters of mercury. And our first volume given V1 is 30 centimeter cube. And we are given the next volume, the next pressure, P2, to be 760 millimeter mercury. And V2 is what we are to evaluate. So from Boyle's law, P1 V1 equal P2 V2, which simply implies that V2 will be equal to P1 V1 all over P2. So our P1 is 650 millimeters of mercury multiplied by V1 30 centimeter cube divided by P2 760 millimeters of mercury. So when you do this, you're going to have approximately 25.657 centimeter cube. So if we evaluate this to two decimal places, our V2 will be equal to 25.66 centimeter cube, which corresponds with option B.